In this question, it's hard to look at the question stem without taking in the data statements as well. This question is going to be a perfect fit for analysis by cases because it's a situation of confusing looking algebra but not great overall complexity. Let's turn to the data statements separately first. To evaluate statement 1 by cases, we can start with a case in which A, B, and C are all 1. This case is permitted because A times B equals 1, as statement 1 requires. In this case, the answer to the question posed to us is yes, because ABC equals 1. We can, however, come up with a valid, contradicting case. Consider this case. A and B are still 1, but C is 1/2. This case is also permitted because AB is still 1, as statement 1 requires, but ABC is now 1/2, so the answer to the question is no. Therefore, we cannot answer the question definitively. Statement 1 is insufficient. Statement 2 is insufficient based on similar analysis by cases. Now, rather than keeping A and B constant and changing C, we can keep B and C constant and change A. In one case it could be 1, in another it could be 1/2. Statement 2 is insufficient. When we combine the statements, we get to keep the case that A, B, and C are all 1. The other cases that we had already come up with are no longer allowed. The question is whether we can come up with a new case that's allowed by both statements that gives an answer of no to the question of whether ABC equals 1. With 1/2 fresh in mind, we can consider whether A could equal 1/2. In that case, statement 1 would require that B equals 2, and if B equals 2, statement 2 would require that C equals 1/2. Indeed, this is a valid case. It meets both statement 1 and statement 2. And in this case, ABC equals 1/2. So we have obtained an answer in the negative to the question posed to us. Once again, we have come up with 2 permitted cases yielding different answers to the question, so we don't have sufficient information. The correct answer is E.